Good morning everyone. Myself Lalitha. I am the Assistant Professor, Department of Electrical and Electronics Engineering, KPR Institute of Engineering and Technology, Coimbatore. In this discussion, we start the discussion in the topic of TRIAC. The expansion of TRIAC is Triode for Alternating Current. In my previous video, I explained the construction, working principle and characteristics of SCR. So in the same case, the SCR disadvantage is it has three modes of operation: forward blocking, reverse blocking and forward conduction. And SCR is a unidirectional device. So to overcome this disadvantage, we go for an TRIAC. So TRIAC is a bidirectional device, current control device. In this, two anti-parallel SCRs are connected. Two SCRs are connected in anti-parallel connection. So in this two thyristor analogy, one anode and cathode is connected to the one terminal, that main terminal 2, and one cathode and anode is connected and considered as one terminal, that is main terminal 1. Two gates are tied together and it is a gate terminal. It is also the three terminal device: main terminal 1, main terminal 2 and gate. So this is a symbol of TRIAC: MT1, MT2, gate. Three terminal device, two SCRs are connected, two anti-parallel SCRs are connected. And one SCR setup we have two PN junction. PN, PN. Another anti-parallel SCR has two PN junction. Totally we have 4 P-type and 4 N-type, P-type and N-type devices in this TRIAC. This is the physical arrangement. The TRIAC is a triode for alternating current, so it is used for the AC power control. SCR is used for the DC power control. So in TRIAC is a three terminal device. They can conduct in both the condition of the gate signal, positive and negative. TRIAC can go to conduction mode if the applied voltage is equal to the breakdown voltage. But the most preferred way of turning on a TRIAC is by providing gate pulse either positive or negative. In the SCR, we are giving the supply between anode and cathode, and the specific gate pulse is given through gate. But in TRIAC, the same case, we are giving the input between the main terminal 1 and main terminal 2, and the positive gate signal also given, negative gate signal also given. We have the 4 conduction mode in the TRIAC. The first condition is MT2, main terminal 2 is positive with respect to main terminal 1 and the gate polarity is positive. The second conduction mode, same, main terminal is positive, main terminal 2 is positive, but the gate polarity is negative. The third case is MT2 is negative with respect to MT1 and the gate polarity is negative. Fourth mode is MT2 is negative with respect to MT1 with gate polarity is positive. In the SCR, we have three modes: 2 blocking state, 1 conduction state. That is reverse blocking, forward blocking and forward conduction. But in the TRIAC, we have the 4 conduction mode. One is forward blocking, second one is forward conduction, third one is reverse blocking, fourth one is reverse conduction. If it is forward, means the input between the MT1 and MT2 is forward bias. If it is reverse, means the input between the MT1 to MT2 is reverse bias. If it is a conduction mode, the gate signal is positive. If it is a blocking mode, the gate signal is negative. So that is the case. So this is the quadrant 1 operation. MT2 is positive and gate signal is positive. In the quadrant 2 operation, MT2 is positive but gate signal is negative. In the quadrant 3 operation, MT2 is negative and the gate signal is negative. MT2 is negative in 4th quadrant and gate pulse is positive. So we have 4 conduction mode: forward blocking, forward conduction, reverse blocking, reverse conduction. So the same TRIAC operation with construction form. So we have the 4 P-type and 4 N-type in the TRIAC. So we shown it like this. So we have the connection between MT1 and MT2, that is either forward bias or reverse bias. If it is a forward mode, means we are giving forward bias. If it is a reverse mode, means we are giving the reverse bias. Likewise in the gate pulse only the source to react the middle junction. So we are giving the TRIAC operation or SCR operation will based on the gate signal only. But in SCR, we are giving the gate signal as positive only. But in the case of TRIAC, we are giving the positive gate pulse as well as negative gate pulse. So in the conduction mode, we are giving the positive gate pulse in both the condition. In the blocking mode, we are giving the negative gate pulse. So that is the case. So the SCR will consider India as a unidirectional device, but TRIAC is a bidirectional device due to this advantage only. So this is the VA characteristics of TRIAC. In the case of SCR, it will be the forward blocking mode and forward conduction mode only. And the SCR, in the case of SCR, in this we have reverse blocking condition only. But in the case of TRIAC, we have forward blocking, forward conduction mode, and reverse blocking, reverse conduction mode. Likewise, quadrant 1, 2, 3, 4 operation. So this is the same case of VA characteristics. So these about the thyristors. We have the electronic devices as diode, thyristors and transistors. In the diode, we discussed about power diodes and Zener diode. In thyristor, we consider the SCR, that is silicon control rectifier, and TRIAC, that is diode for AC, alternating current. So the SCR will used for DC power flow control, TRIAC is used for AC power control. And now we move for transistor. The transistor is also the important electronic device. In the transistor, we consider the bipolar junction transistor. It is simply called as an BJT. So in BJT, we have the three terminals, emitter, collector, base. We have two type of transistor. One is PNP, another one is NPN. The P type is sandwiched between two N type. It is NPN transistor. The N type is sandwiched between two P type. It is a PNP transistor. So this is a symbol of NPN transistor. The arrow mark, the current flow direction will be reverse in NPN and PNP. So a BJT is a type of transistor in which the current flow between the collector and the emitter is controlled by the amount of current flows through the base. Its operation depends on the flow of majority and minority carriers. It is a principal, it will act as an amplifier and also act as a switch. So BJT has three modes of operation: common base configuration, common emitter configuration, and common collector configuration. It has the three regions in the characteristics. The regions are active region, saturation region, and cutoff region. In common base configuration, we have three terminals in BJT: base, emitter, collector. The base will be grounded, and we can consider the emitter and collector is input and output. So in that case, the voltage, it has voltage gain but no current gain. In the common emitter configuration, the emitter will be common, that is grounded, and the base and collector will consider as an input and output. In that case, we have both current and voltage gain. So in common collector configuration, the collector will be grounded, the base considers the input, and the emitter will be output. So it has current gain but no voltage gain. In these three configurations, the usually used method one is common emitter configuration. So we have the three modes of operation in bipolar junction transistor. So the three regions are active region, saturation region, and cutoff region. In the cutoff region, the transistor is in off state. In saturation region, the transistor in fully on state. In active region, the transistor operates as an amplifier. So this is the BJT operating regions: cutoff, saturation, and active, and also the breakdown. So in the cutoff region, the base current is very small, and base collector and base emitter junction also reverse. So in this case, the transistor will act as a open switch. In saturation region, the collector emitter voltage is small, and the base emitter and base collector supply is forward. In this case, the transistor will act as a closed switch. In the active region, the VC is increased from small value to moderate value. In that case, the base collector supply is reverse, but base emitter supply is forward. In that case only, the transistor will act as a amplifier. So in breakdown region, if the VCE is higher value, then VC base collector and base emitter voltage is beyond the limits, so it's considered as an overload. So this is the BJT construction. It is the doping concentration of P-type and N-type. So this is the characteristics of BJT, input characteristics, output characteristics. In every configuration methods, we have the input and output characteristics. It is considered for CE configuration. In that case, the input voltage is VBE, input current is base current. Output characteristics, the output voltage will be between collector and emitter. Output current is collector current. When we are VC is IB is 0, it enter into cutoff region. When the VC is small, it will be a saturation region. When the VC is increasing by fixing the base current, then we can get the collector current. So it shows the output characteristics. Likewise, in the input characteristics, the VBE will be gradually increased. Based on this, the IB current will be increased. Thank you.